to the next point.
Towards
We should ensure
us.
whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
My wonderful viewers, listeners, and learners at home, you are welcome once again to the Kaduna State Ministry of Education radio, television, e-learning platform. My name is Mr. Philip Mamman, your chemistry teacher. And today in chemistry, I will be taking you through organic chemistry. And remember in my last lesson, I said the alkanols is divided into two series. So today is series 2 of alkanols. Follow me from where we stopped last class or last lesson. Remember in our last lesson, we did define what alkanols are. We say that they are organic compounds that contains carbon, hydrogen, and oxygen. And they have a general molecular formula of CnH2n plus 1OH, where the N is a whole number, such that if N is equals to 1, is the first member methanol. If you substitute 1 in that molecular formula, you have CH3OH. We also try to look at the classification of alkanol. We say alkanols can be classified based on the number of OH. If they have one OH, they are called monohydric alkanol. If they have more than one OH, they are called polyhydric alkanols. And polyhydric alkanols can be divided into two. Dihydric alkanol, that means having two OH, and trihydric alkanols having three OHs. And I gave an example of monohydric alkanol. I mentioned ethanol. Then I gave an example of dihydric alkanol as propan 1,2-diol. Then I gave example of trihydric alkanol as propan 1,2,3-triol. Now, we also went ahead to look at the different type of monohydric alkanol. We say monohydric alkanol can be divided into primary, which is first degree alkanol, secondary, which is second degree alkanol, and tertiary alkanols. And we say in the primary alkanols, the carbon atom that is carrying the OH group is attached to only one other alkyl group or one carbon atom. Or in other words, the carbon atom carrying the OH group is attached to two hydrogen atoms. But for a secondary alkanol, the carbon atom that is carrying the OH group is in turn attached to two alkyl groups, both front and back, or is attached to two carbon atoms or one hydrogen atom. And lastly, the tertiary alkanols have the carbon atom carrying the OH group attached to all three alkyl group or three carbon atom, or we say is attached to no hydrogen atoms at all. I'm sure I have refreshed your memory. We went further to look at the IUPAC nomenclature of alkanol, and we say you must observe the longest chain rule, which says identify the longest chain and give it the parent name. And I say if the longest chain is 7 carbon atom, it becomes heptanol. Remember, you can always indicate the position of the OH group. If the OH group is on carbon number 2, it becomes heptan2ol. Now, how do we know the position of the OH group? By following the numbering rule. The numbering should be done in such a way that the functional group, which is the OH, is given the lowest number. Then we have the alphabetical order rule and the comma and hyphen rule. Today, we'll be looking at laboratory method of preparation of alkanols. Now, one of the methods you can prepare alkanol in the laboratory is through hydration of alkenes. An alkene is a double-bonded hydrocarbon with general molecular formula of CnH2n. So if you are picking, for instance, ethene, you treat it with tetraoxosulfate 6 acid to get ethyl hydrogen tetraoxosulfate 6. It is the ethyl hydrogen tetraoxosulfate 6 that is treated with water to give you your ethanol and your tetraoxosulfate 6 acid. So we say ethene is bubbled through concentrated tetraoxosulfate 6 acid at a temperature of 80 degrees centigrade under pressure. And ethyl hydrogen tetraoxosulfate 6 is obtained, which is treated with water to give ethanol on distillation. That's how you can get ethanol in the laboratory. Remember, you can get other members of the homologous series following the same procedure. We know members of homologous series have similar method of preparation. That's one of the properties of homologous series. Then industrially, how do we prepare alkanols? Now, There are activities that we carry out in our houses, which is similar to this. Those of you that make kunu at home, or those people that make local brews like burukutu, as the case might be, they follow this procedure. Usually it's through a process called fermentation of starch. Starchy material can be your maize, guinea corn, millet, cassava, yam, rice, sugar cane, as the case might be. Any of these materials can be applied in this process. Now, what is fermentation? The slow decomposition of large molecules such as starch into smaller molecules such as ethanol by microorganisms is called fermentation. That is fermentation processes. Now, sources of starch include cassava, potato, sugarcane, etc. The cassava is peeled, sliced, and steamed with supersaturated steam. This releases starch from the cassava. Then this cassava malt is added to the mixture, and this mixture is kept at a temperature of 50 degrees for 1 hour. The enzyme diastase from malt converts starch to maltose, and starch has the empirical formula of C6H10O5, all in brackets N, where N is a whole number. Remember I said to you that you can get your fermentation process done when you decompose starchy materials. I say, first of all, you will peel this cassava, which is the starchy material. If it is maize, you know that maize does not need to be peeled because already it is peeled from the farm. Then if it is potato, you need to peel. If it is yam, you need to peel. Any of this material can be adopted for this procedure. First of all, you will steam it with supersaturated steam such that starch will be extracted from the material. Then you treat it with malt, and malt will release an enzyme known as diastase. And the diastase will convert the malt from the starch to maltose. And this maltose is the one that we will continue with in the next process. Now, you can see the starch there. It has been heated with, it has been supersaturated steam, and you get your maltose. Yeast is then added at room temperature. The enzyme maltase from yeast convert the maltose to glucose. So you can see your glucose there as it has been portrayed on the equation. That means from your maltose, after being reacted with maltase, an enzyme, it will convert the maltose to glucose. And your glucose is glucose and fructose. And eventually, this another enzyme, zymase, also from yeast, convert glucose to ethanol and carbon dioxide. I will take that again. I said that when your cassava is peeled and heated with supersaturated steam. Now, this steam extracts the starch from the cassava, and malt is added to the starch, which converts the starch to maltose. Now, it is your maltose which reacts with another enzyme, which is maltase, and convert the maltose to your glucose. Now, glucose is then reacted upon by an enzyme known as zymase from yeast, and it converts the glucose to ethanol and carbon dioxide. Now, the carbon dioxide appears as bubbles in the mixture. The resulting liquid mixture, which contains about 18% ethanol, is fractionally distilled to obtain ethanol. The ethanol obtained is about 95% pure at that process. Now, you can also get it typically from sugar cane, but look at it. A typical alkanol, ethanol, is a colorless liquid and volatile. It is readily soluble in water and is neutral to litmus. You get to find out why ethanol is soluble in water as we proceed. But like I said, you can get it also from sugarcane. If you are getting it from sugarcane, remember that sugarcane is sucrose. You don't have to follow through the process of converting starch. Already is sucrose, which is a disaccharide or oligosaccharide. So when the sucrose react with water an enzyme invertex at 30 degrees converts it directly into glucose and fructose. And it is this glucose that is acted upon by Zymes, which is an enzyme, and it converts it to ethanol and carbon 4 oxide. Like I said earlier on, the solution is subjected to fractional distillation to obtain a fraction containing about 95.6% of ethanol. This could further be dehydrated to obtain absolute ethanol with 99.5 degrees. Ethanol with use of calcium oxide. So this is so far how we can prepare ethanol in the laboratory. Like I said, in a homologous series, they have similar method of preparation. So other members of the homologous series can be prepared as well. Now, the physical properties of alkanols. Alkanols are neutral substances. It means that they are not acidic, they are not basic. If you put a litmus paper, it will not change. Then, of course, the lower members, such as methanol and ethanol, are liquid. Like I said, they are volatile liquid. What do I mean by volatile liquid? If you dip your hand into it and bring it out, it will vaporize fast, as in the case of your perfumes. You see, if you put perfume on a shirt or something, it will vaporize quickly, leaving the fragrance on your shirt. So we say ethanol are liquid and have characteristic smell and a burning taste. Those people that take alcohol will agree with me that it has a burning taste on their throat. That's the characteristics of alkanol. The higher members are solid and are almost odorless. Alkanol generally has high boiling point because of extensive hydrogen bond. Now, I told you that you get to find out why ethanol is soluble in water, because we said earlier on that organic compounds are insoluble in water because they are covalent in nature. But alkanols has hydrogen bond because of the bond between the oxygen and hydrogen in the OH. And that hydrogen bond is responsible for their high boiling point and also responsible for their solubility in water. Remember that this boiling point increases with an increased carbon number. That means from ethanol to propanol to butanol to pentanol. In that sequence, the boiling point increases, such that boiling point of ethanol and butanol is 78 degrees centigrade and 118 degrees centigrade respectively. The lower alkanols are very soluble in water. This solubility decreases as the molecular weight increases. Remember I said that the solubility is also because of hydrogen bond. My wonderful students, I have stretched you this far, and I hope that you are not tired yet. Pay attention because we'll soon be concluding this lesson. And this concluding aspect is very, very interesting, which is the chemical properties of alkanol. Now, dehydration of alkanol will give you the corresponding alkene. For instance, what is dehydration? Removal of water. So if you remove water from ethanol, which is C2H5OH, using concentrated tetrasulfate 6 acid in excess, you will get ethene from ethanol to ethene and water. So dehydration of ethanol will give us ethene, meaning that if you dehydrate propanol, you will get propene, as the case might be. Now, when ethanol is in excess, ether is formed, as you can see in this case. If you put excess ethanol instead of excess tetrasulfate 6 acid at the temperature of 145 degrees centigrade, in presence of concentrated tetrasulfate 6 acid, you will get ethioxyl ethene, which is an ether, ethioxyl ethene, which is an ether, and water. So that's the first chemical reaction that these alkanols undergo. The next chemical reaction for alkanols is the reaction with alkanoic acid. And that reaction is called esterification reaction. Now, esterification reaction is the reaction between alkanol and alkanoic acid to give a pleasant fruity smelling substance called esters. These esters are generally called alkanoids. We will be seeing this subsequently in our next lesson when we'll be discussing alkanoic acid and consequently its derivatives. Now, the reaction alkanol reacts with alkanoic acid in the presence of concentrated tetraogosulfate 6 acid acting as a catalyst to form alkanoid. Remember I said another name for alkanoid is esters. Example is an alkyl group, an OH, which is alkanol, then an alkyl group with COOH, which is alkanoic acid. to give you an alkyl group, COO alkyl group. That is an alkanoate plus water. Let's take an example. Methanol reacting with ethanoic acid. You see that the H in alkanoic acid will combine with the OH in the alkanol, and it will give you water. While, of course, the two other residual will combine to give you methyl ethanoate. It will give you methyl ethanoate. Then the second one is C2H5OH, which is ethanol, plus ethanoic acid to give you ethyl ethanoate. In our next class, we'll be looking at alkanoic acid and its derivatives. And consequently, we'll see how you can name alkanoates in that lesson. Now, the other reaction is oxidation of alkanols. Primary alkanols can undergo oxidation to give you alkana partially, then completely to give you alkanoic acid. So primary alkanol undergo oxidation to give you alkana and then alkanoic acid. For instance, the oxidation of ethanol will give you ethana, then of course ethanoic acid. The reaction is of two stages. Look at it here. You have ethanol undergoing oxidation to give you ethana and water. Now this ethana and water will undergo further oxidation to give you ethanoic acid. That's the other one. So for secondary alkanols, as you can see here, ethanol will undergo oxidation, complete oxidation to give you ethanoic acid and water, as the case might be. And propanol can undergo complete oxidation to give you propanoic acid and water. So generally, I said that primary alkanol can undergo oxidation to give you alkana, then alkanoic acid, as I've been mentioned. Then secondary alkanol can undergo oxidation to give you alkanones. Now if you look at the equation, you will see the example there. Propan-2-ol, which is a secondary alkanol, can undergo oxidation to give you propanone. Propanone, formerly the alkanones were known as ketones. So we have the aldehyde, which is alkana, and the ketones, which are the alkanones plus water. Tertiary alkanol does not undergo oxidation under ordinary conditions. And that is why you have seen the oxidation of primary alkanols to give you alkanol and alkanoic acid. And of course, the oxidation of secondary alkanol to give you alkanol, to give you alkanones. So, oxidation of dicarboxylic acid. Now, remember I said our diols, okay, can also undergo dihydric alkanols, like our ethane 1,2-diol. When you react with HNO3, you will get ethane dioic acid. Look at the equation in our next slide. Look at it. Ethane 1,2-diol plus 4 molecules of oxygen or plus oxygen in the oxidation process, you will find it will give you ethane 1,2-dioic acid plus water. I'll quickly take this reaction because it came out in the just concluded WAEC examination under the practical aspect where you were to test for the functional group alkanol. It's called the iodoform reaction. This reaction, this is a reaction whereby a mixture of ethanol, a few crystals of iodine, and washing soda is heated at 70 degrees to give a pale yellow crystal triiodomethane, which is known as iodofoam. On standing, methanol does not give the similar reaction. Hence, a test for distinguishing between ethanol and methanol or primary alkanol and secondary alkanol. As the statement has said, only ethanol undergo this reaction in the primary alkanol. So you can also use it to identify ethanol and also secondary alkanols. Now, we'll be rounding up our lesson by looking at the assignment. That is the test for alkanol that we have said earlier on. But before I go to that, I just want to run down what I have said earlier on. Remember, I told you that alkanol are organic compounds that contain carbon, hydrogen, and oxygen. They have a general molecular formula of CnH2n plus 1 OH. And they can be classified into monohydric and polyhydric. Remember, I say monohydric alkanol has only 1 OH, and polyhydric alkanol has 2 OH in dihydric and 3 OH in trihydric. I said monohydric alkanol can be divided into primary, secondary, and tertiary alkanol. And I said in primary alkanol, the carbon atom that is carrying the OH group is in turn bonded to 2 other carbon atoms, or is in turn bonded to 2 alkyl group, or is, in primary alkanol, the carbon atom that is carrying the OH group is in turn bonded to 1 other carbon atom, or is in turn bonded to 2 hydrogen atoms. Like I said, that's the primary alkanol. Then the secondary alkanol, the carbon atom that is carrying the OH group is in turn bonded to 2 other carbons, or 2 alkyl group, or 1 hydrogen atom. And lastly, the tertiary alkanol, the carbon atom carrying the OH group is in turn bonded to 3 other carbon atoms, or no hydrogen atoms at all. Then we went further to look at the IUPAC nomenclature of alkanol. Remember, I said obey the longest chain rule, then the numbering rule. Longest chain rule states that identify the longest chain and give it the parent name. The numbering rule states that numbering is done in such a way that the functional group, which is the OH, is given the lowest number. Then we say the alphabetical order rule. When you have alkyl groups, they should be arranged in order of increasing alphabet. Then lastly, we say numbers are separated by commas, and number and alphabet is separated by a hyphen. We look at the method of preparation of alkanols. We say alkanols can be prepared in the laboratory by the reaction of an alkene with water via concentrated tetraogosulfate 6 acid. For instance, ethene can react with concentrated tetrasulfuric acid to give you ethyl hydrogen tetrasulfate 6, then later with water to give you ethanol and water. Now finally, I would like to stop here and give you my assignment for the day. It says, write the general molecular formula, condensed formula, structural formula, and name of the first 10 members of the alkanol family. Then number 2 says, give one example each of the following: monohydric, dihydric, trihydric alkanol. 2, primary, secondary, and tertiary alkanol. Number 3, describe the preparation of ethanol starting from cassava. Then lastly, write the complete balance equation of the oxidation of primary, secondary, and tertiary alkanol. You have done well sitting to listen to me this wonderful day. I hope you will make use of those things that you have learned. I was happy that you actually listened today. Join me another day as we're having another interesting aspect in chemistry. You can lay your hands on any of this material. Understanding Chemistry by Godwin O. Ojokuku, New School Chemistry by Ashao Yao Ababio, and of course, the last one, Stand Chemistry by Science Teachers Association of Nigeria. Have a wonderful day. Stay and keep learning. Stay away from trouble. Stay away from coronavirus because it is real. Maintain the social distancing and the protocol of the Ministry of Education. My name is, as always, Mr. Philip Maman, and my phone number is 080-2659-8861. Again, 080-2659-8861. Have a wonderful day. Thank you.